Hello, fourth grade math stars. Today we will be working on this lesson 5 problem set. And as you can see, it deals with fractions. So pretty much what we're going to be doing from now moving forward is fractions. And some of you guys might not have seen fractions before. Some of you might not have seen fractions since 3rd grade, but that's totally okay. This is totally doable. This is actually a 3rd grade module, so this will just be pretty good review for us, okay? So let's do some practice problems, let's do some review, and then you guys should be all good to go. Okay, as you guys might have learned or in the earlier grades, we know that a fraction is pretty much just a number that is not a whole number. So no whole, okay? So that means it's parts of a whole number. So have you ever, let's say your family orders a pizza, right? Okay. Is your family just going to give you the entire box of pizza just for you to finish by yourself? Or are you going to share the pizza? You're probably going to share the pizza, right? So let's say you're a family of 4. You each would want to get a slice of the pizza, right? Okay. And fractions help us with that with this math problem. So if you're a family of 4 and each family member is getting 1 slice of pizza, then each family member is essentially getting 1/4 of the pizza. And we would express that 1/4. Your numerator is the number on top. Numerator. And then your denominator is your number on the bottom. Okay? And your denominator is essentially the total number of pieces. The total number of pieces. And then your numerator would be the amount of pieces of pizza that each person gets. Okay? So if you're a family of 4, it would make most sense for each person to get 1 slice of pizza. And that would be your numerator, your number on top. And your denominator is your number on the bottom, and it is the total number. So 1, 2, 3, 4. So 4 would be our denominator because it's the total number. Okay, so let's move on to this problem set. So there's 4 boxes here, so 4 questions, okay? And we are going to use this first triangle diagram for problem number A. Okay, so the first problem asks total number of equal parts. So we're just going to count the total number of equal parts. So it appears to me that there are 2 triangles here, right? 1, 2. So I'm just going to simply put 2 in the X box because it's the total number of equal parts. Next one asks total number of equal parts shaded. So what does it mean to be shaded? So it's essentially asking how many boxes or how many triangles are colored in. As you can see, there's only 1 triangle that's colored in. Okay, so I would put 1 here. Next box asks for unit form. So unit form is essentially just a fancier way of saying we're going to put this in proper word form. So this is just going to be, actually, let's move on to fraction form first. Because fraction form is essentially the form we put up here with the pizza. So we have our numerator on top and our denominator on the bottom. And our denominator is just the total number of parts. So in total, how many parts are there? Well, we already decided that that's 2. So my denominator is 2. And numerator, we decided that that's going to be just the shaded. So just shaded will be the numerator. So how many shaded pieces did we find? We just found 1. So my fraction form is 1 over 2, or this is also 1/2. Okay, that's our unit form, that's our word form, 1/2. Okay, because 1/2 of this triangle is shaded. Okay, let's move on to this next problem. I'm going to do B with you, and then you guys can do C, D, E, and F on your own. Okay, so B, let's start with the total number of equal parts. So let's count how many boxes there are in this diagram. 1, 2, 3. Do you guys see that? There are 3 parts in this diagram, 3 equal parts. How many of those parts are shaded? So how many are colored in? Well, just one is, right? Just one. So let's move over to the fraction form. I'm going to have my numerator on top, my denominator on the bottom. So denominator, what is the total number of parts? Total number of equal parts. So we decided that was 3. And then what's the total number of equal parts that are shaded? So how many are colored in? Well, we decided that that's just 1. So our fraction form would be 1 over 3. And how we would write that in unit form is 1/3. Okay, because 1 over 2 is 1/2. So 1 over 3 is 1/3. So we have halves, we have thirds, we have fourths, fifths, sixths, sevenths, etc. Okay, so your job is to do C, D, E, and F on your own. And then let's move on, because you guys also have the back page, which is still lesson 5 problem set to do today. So let's do a review problem, or let's do one of them together. And then you guys can try numbers 3 and number 4 on your own. Okay, so our problem asks, Andre's mom baked his 2 favorite cakes for his birthday party. The cakes were the exact same size. Andre cut his first cake into 8 pieces for him and his 7 friends. The picture below shows how he cut it. Did Andre cut the cake into eighths? Okay, so eighths. What is an eighth? An eighth is just 1 over 8. So we're just going to make sure that he cut the cake into eighths, meaning he cut the cake into 8 pieces. And we're going to figure that out by counting the amount of pieces that Andre cut. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 pieces here, right? So did Andre cut the cake into eighths? Yes. Why? Because there are 8 pieces. Okay, so we could write yes, 8 pieces. Okay, 8 pieces. Okay, so Andre and each one of his friends is essentially just getting 1/8 of the cake. Okay, because they're just going to get 1 piece, and there's 8 pieces total. So our numerator is 1, our denominator is 8. So question 3, you guys will be working on this question on your own, but it asks, 2 of Andre's friends came late to his party. So if 2 friends came in late, and there were 8 people to begin with, how many people are there now? We'll do addition. 8 plus 2 is 10. They decide they will all share the second cake. Show how Andre can slice the cake so that he and his 9 friends can get an equal amount with none left over. What fraction of the second cake will they receive? So what you're going to do, math stars, is you're going to cut this cake into 10 equal pieces. Okay, you're going to cut that cake into 10 equal pieces. And now, question 4. Andre thinks that it's strange that 1/10 of the cake would be less than 1/8 of the cake, since 10 is bigger than 8. To explain, Andre drew 2 identical rectangles to represent the cake. Show 1/10 shaded on one and 1/8 shaded on the other. Label the unit fraction and explain to him which slice is bigger. So, down here, math stars, what you're going to do is you're going to represent, here, let me write this better. For our first cake, Andre cut it into eighths, right? So 1/8. So you're going to essentially cut this cake into eighths. And it's already done for you up here. And down here, we're going to cut this cake into tenths, which you already did over here. And now you need to think about why this cake is going to end up being smaller than this cake. Let's think for a second. Why would this cake be smaller than this cake? Or why would each piece be smaller in this cake than this cake? Okay, so a hint is because we are going to break this cake into 10 pieces, and this cake will be 8 pieces. So that means that this cake, each piece would be smaller than this cake. Okay, so your job right now is to do the rest of the first page on your own, and then these 2 pages on your own. Okay? Please join office hours if you have any questions. See you later, math stars.